Okay, so 3-1, we're going to be graphing polynomial functions. We're supposed to predict behaviors of polynomials. That's what we're supposed to be doing. Maybe. There we go. Standard form of a polynomial. All the like terms are combined and the terms are written in degree descending order. Is this what I have in standard form? No. It should be 2x cubed minus 4x plus 9. Now I'm going to tell you it is never going to kill you to put these in the right order, whether you have to or not. There is a question on a pre-calculus test that I've given, and the same question, different numbers, but the same question has been on my test for now 19 years. And every year I have about one student get it right. Because they don't put it in what before they start? Order. They don't put it in standard form before they start. And if you don't put it in standard form, you're not going to get the right answer.
Miss Mick, I kind of forgot that you taught somewhere else for a minute.
Mm-hmm. Oh, you're she's going to be here 1 year. Okay, so standard form just means that it's in descending order alphabetically. So if you have x and y's, x's go first, right? Then y's. But if you have t's and s's, s's go first, things like that. Okay, leading coefficient is the non-zero factor that is multiplied by the greatest power of x. So in this polynomial right here, what is the leading coefficient? 2. Leading coefficient is 2, correct? Now, negative 4 is also a coefficient, but is it the leading coefficient? No. And a leading coefficient cannot be found until it's put in order. Degree of the polynomial is the greatest degree of any of the terms. So of our example, what is the degree of this polynomial? This is 2.
9.
Nope.
2x.
What is the greatest degree on any of the terms? The degree is 3. 3 is the highest degree, correct?
Oh.
So our example is degree of 3.
What's the degree?
An exponent?
Yeah.
An exponent? If you don't know what that is, should you put an exponent?
Mm-hmm.
Yes? Now, again, if you put it in order, would you know right away what it is?
Yeah.
Yeah. So on our examples, what is the standard form, leading coefficient, degree, and the number of terms? Okay, so A, is it in standard order? Or standard form? Nope. Which one has to go first?
The 3x.
Okay, so negative 3x to the fourth.
Then the negative 5x.
Then negative 5x cubed.
Yeah. And then 2x
So plus 2x
plus 6.
plus 6. So the LC standing for what? Leading coefficient is?
Negative 3x.
Nope, just negative 3.
Okay.
Coefficient's the number.
The answer is minus 3 times x.
Cheating.
Okay, what is the degree of the polynomial?
1 and 3.
Nope,
4.
4. And how many terms?
4.
Is this all we have to figure out?
No.
We're going to be graphing.
This is the first slide.
Sometimes, Miss May.
Okay,
Make it this.
do the next problem on your own.
Wait.
Yes.
I don't know how to do it.
I'm still
She
writing.
said do the next problem.
All I said was
I know, I'm still writing down the notes.
this right here. Okay. Kyson, the next problem, put it in order.
Is this going to be hard?
Yeah, you don't even know how to do it. I was writing notes. Carla, what do you think?
Okay, what's your biggest exponent?
6.
So put it first. Put that term first. What term goes with the 6? Kyson,
What?
2x to the 6th. What's the next one?
8. Wait, 8's big.
Exponent.
Oh, 3 and 4. No, x 5.
5. So plus x to the 5th. How did I know it was plus?
Because they're
Because it's not negative, right?
yeah,
What's next?
3, 4
Okay, so 3. So plus,
minus.
plus.
Yeah.
Oh, wait, no, sorry. You're right. So minus what?
3 x to 4.
Uh-huh, what's next?
4 x
Plus or minus?
plus 4 x to 3. Third.
Okay, what's next?
X. Wait, no. Minus 8x.
Okay. What's the leading coefficient?
Leading coefficient should be right after. X.
Coefficient is a
5.
number.
Uh,
A non-zero factor
8x.
that is multiplied by the greatest power.
2.
So the greatest power, yes, is 2. What is the degree?
Probably
The biggest degree.
6.
6. And how many terms?
2. 1, 2, 3, 4, 5. 4.
There's 5, you're right.
I literally was
That's
not
it?
here.
Yep.
Okay, we're not moving on.
Okay, so did you guys get what Kyson got?
Yeah.
Ainsley, did you get it?
What's your degree?
6?
Yeah.
Okay.
Bachelor's.
Did you just take it? Sure.
Advanced.
Tyson, do you want me to bring up a picture?
Okay, and behavior. Now, there's a lot of stuff on this slide. Do not just start writing everything because we'd be here all day and you don't need it. I want you to listen. Taking good notes. Listen. Taking good notes is writing what is going to be meaningful to you, and this whole slide is not going to be meaningful to you, is it?
No.
Okay, so it is there so we can see the picture. End behavior of a polynomial. You can write this first part. End behavior of a polynomial function describes what happens to the y values as x approaches positive and negative infinity. Only. Cut and dry. It's what's happening over to the left and what's happening over to the right. Okay? That's all it is. Nothing else. Got me? It tells me where it starts and where it stops and nothing about what happens in the middle. Clear? Okay. When you guys have that first thing written down, put down your pencil and look up at me. You just starting to write it?
Kyson, it's recorded. Okay.
You act like those pictures are gonna help you when you go home.
It will. I'll copy them off.
You will not.
And Williams might.
But there's
My
a
notebook.
video that has the
Can't
notes
copy
on
them.
there.
Okay, just shush. Shush. No, my only comment was we sat there for 3 minutes before you started writing.
Oh yeah, because I was thinking if I should write it or should I copy it off and then glue it in here.
It's a very hard decision.
It is. I made a
You
decision.
can copy this
Do
stuff
both.
off.
Okay, so I want everyone to look up here. I have odd and even. What's odd? What's an odd number?
1,
One.
3, 5,
3,
7,
5,
9.
Okay.
Let's go to 1,000.
What's an even number?
2,
2,
4,
4,
6,
0.
Okay, so when I'm talking about odd degrees, I'm talking about the highest degree is odd. Got me? When I'm talking about even degrees, I'm talking about the highest degree is even. Not what else is in there. Just the very first one. So I have to have it in standard form before I start, correct? Okay. So When I have a graph that is a first degree, again, do not write. I want you to observe and absorb. Okay, a first degree is a linear equation, yes?
Yes.
Does it starts down, yes?
Yeah.
And ends
Up.
up. Could it start up and end
No.
down?
Yes.
Yes. Okay, but it's starting and stopping in opposite directions, isn't it?
Yeah.
Okay, so then when I go to cube, it's blue one. What do you notice about it as well? It starts down and ends up. It's starting and stopping in a different order, isn't it?
Yeah.
Okay, I have 2 to the x to the 5th. So it starts down and ends up. Okay, so do you notice that this x, what's the coefficient on the x?
1.
1. What's the coefficient on here? 0.5. What's the coefficient on the green? 2. They're all positive, yes? So they're ending, when we talk about end, we're going from left to right. They end going where?
Right.
Up.
Up.
Are they ending up?
Yeah.
Every single one of these graphs ending up?
Yeah.
Yes? And then, so if they end up, they had to start where?
Down.
Down. Okay? So for odd functions, what I want you to write on your paper is the arrow, what it's pointing out. Odd degree, positive leading coefficient. I want that. Odd degree, positive leading coefficient. And then you just draw a picture that looks like this. Does that symbolize what happened in every single one of these graphs down here? Did it start down and end up?
Yeah.
Yes. It's end behavior. Get it? What I'm saying? So I'm talking about what's happening on the right. So odd degree, positive leading coefficient. So it's positive, so it's going to end up, so it had to start where?
Down.
Down. Clear what happened there? Okay, everyone done writing that?
Yeah.
Okay, next visual. Do not write the whole thing again. I have even number, 2, 4, 6, 8, 10, 12. Correct?
Yeah.
Cole, what's wrong?
That's what you're supposed to draw.
Oh.
Just
Not
this.
that, not the graph.
Not the graph, just this, Cole.
Oh.
Cole's like, how's everyone done? This is an art piece.
I was looking at it, roll, and I was like, doesn't seem right.
Thanks for looking out for him, Blaine. Okay, so we have even, positive. Okay, so I have x squared. That's the red. It's a parabola. Yes? I have 0.9x to the 4th. It's the blue. It has a little crook in it. I have 2x to the 6th, the green. What do you notice about all of them?
Parabolas.
They're- well, kind of. They start up and they end where? Up. They're even, so they're going to end up, but I'm sorry, they're positive, so they're going to end up just like the odd, but they're an even. Anytime you have an even function, they end in the same direction. Odd looks odd, even doesn't.
Even looks like a parabola.
Well, kind of, because you usually have whirlies in there. Okay, so you're going to write even degree, positive leading coefficient. What are my ends going to do then? Up. So guess what you're going to draw? 2 up arrows.
Miss Mac, I gotta say, you've gotten so much better at writing with us since we started school.
I know. My palm has been writing a lot today, though. Like in other ones, I don't know if it's touchy earlier, but anytime I lay my hand on it, it gets like all. No, don't be saying it's a parabola because they're not all with parabolas. They could I could do this.
That's a parabola in my eyes.
Well, what about all that?
That's just a weird parabola.
Oh, okay.
Just a messed up
They're
one.
just mini parabolas.
Okay.
Yeah.
So, everyone got their evens? Their even and odd positives?
Yes.
Yes?
They're both pointing down.
Okay. Now, guess where we have to go? Even and odd what?
Middle.
Negative. Negative. Okay, so again, don't go writing. Wait for me to explain.
Is there a negative degree?
Okay, no. odd degree, 1, 3, 5, 7, 9, right? Negative leading coefficient. So an odd degree positive leading coefficient ended up and started down. What do you think a negative leading coefficient is going to do?
Start up and down.
It starts up and ends down. So you're going to put odd degree negative leading coefficient. You're going to start it up. Oh, shoot. I've not gotten better at that, though. I have to put my pin on and I forget. It starts up and ends down. And I'm going to tell you guys, when you ask me the end behavior of an odd function, I'm going to say it's negative, so it ends down. So that means it started up. I always do my end first because we go left to right, don't we?
Is this the same thing we just did?
Yes.
No.
Well, I would have put both of those together. Like the last slide and this slide, they need to be together. That concept is a together thing, correct?
It's just like the
Kind of, yes. Okay, now I have even degree negative leading coefficient. So even positive was up, up. So even negative is what? Down, down. So you're doing the words and the down, down. So now if I look at a polynomial, could you tell me whether it's odd or even?
Yeah.
Yep. Could you tell me how the ends go?
Yeah.
Yep. No matter what I threw, I didn't ask how the middle looked, did I? Just the ends. Am I good?
Yeah.
Angela, you good?
Yeah.
Okay, you're still writing, so I just making sure. Okay. So it says use the leading coefficient and the degree of the polynomial to determine the end behavior of the graph. Okay. First of all, it has to be in standard form. Is it in standard form?
Yes.
Yes. Okay? It's in standard form, so we're good. Is the leading coefficient positive or negative?
Positive.
Okay, so we have a positive, and it's what? Even. I have a positive even.
Going up.
So it's going to end up and it's going to start
Straight up.
up. Guess what we just did?
The homework?
We just did it. Not all the homework. Okay, now I'm going to tell you that if you look in the textbook, this is what it says. You ready? As x approaches negative infinity, y approaches positive infinity. And as x approaches positive infinity, y approaches positive infinity. Well, isn't that what we just said?
Yeah. Basically.
Because negative infinity is on the left, right? Yes? And we said y is going where? Up. And positive infinity is on the right, and we said y is going what? Up. So do you want to do it their way or my way?
Your way.
My
I
way?
don't know what you just did.
Do you want us to write this?
No, I'm telling you if you would look up the answers in a book, or if you would decide to go to somewhere Slater and get answers, you're not going to get the answers I'm looking for.
So what answer do you want?
So now you give
What
a-
answers
even,
do I
up,
want?
Plus even.
I want plus, even, up, up.
How do you get that? Like, will there be a picture of a graph? and
No,
you have to-
off of this equation. Right here. Is 2 positive or negative?
Positive.
Positive.
Two positive.
Is 6 even or odd?
Even.
Even.
So that means it goes
Oh,
up,
that's
up.
easy.
Up, up.
So
Up, up.
Tyson,
Up, up.
it's even and it's positive, so it's up, up,
Up, up.
Up, up.
up, up.
Up,
Next one, do on your own.
down, up.
up, down.
It's down, up.
One of you's right.
It's me. Carly's stupid. I know this stuff.
Negative leading coefficient.
Okay, so pay attention.
Is it? You're not wrong. It's up, down.
Okay, Kyson, is the leading coefficient positive or negative?
I'm trying to work.
Look at it. Is the leading coefficient?
It's the negative.
It's negative. Is the power, is the highest degree even or odd?
Even.
Tyson, look at
Odd.
it carefully.
It's odd.
There you go. Shut up.
Okay, so it's a negative odd, so that means it's going to end down, so it had to start
Up,
up.
up, up. Up, down.
So you were wrong.
That's right.
I believe Kyson, you're right.
Questions, guys?
No.
Don't move on.
Okay. Graph the polynomial function using points. Identify the turning points, relative minimums, maximums, and find the average rate of change over the interval of -2, 0. That is a lot. Yeah?
Yeah.
That is like,
Break that down.
woo.
No,
Yeah.
I just don't understand.
So-
Find the average rate of change.
Slope,
That's easy.
slope.
Do it.
Okay.
Negative 0.5.
So we're not there yet. So there's a lot of stuff there, yes? So it says graph the polynomial function using points. So that means I have to plug points in and get points out, don't I? Yes?
Yeah.
Okay, so 0.5 is 1/2, isn't it?
Yeah.
Yeah?
Yeah.
Okay, so do you guys want to leave it 1/2 or do you want to leave it 0.5? What do you want to do?
Leave it.
Leave it? Okay, so my rule is you have to have 3 odds, a 0, and 3 positives. Not odds, negatives. So it says pick points, yes? It says using points. So I have to pick x's and find y's. How do I find y's from x's?
Put the X's in the thing.
Right? And we've done that before. Didn't we do that in chapter 1?
Yeah.
Yep. It's not very efficient, but we know how to do it, don't we?
Yeah.
Okay, so 1, 2, 3, 0. And 1, 2, 3. Okay, so what negatives do you want to do?
-2 and -4.
Do you want us to write this down?
You might be helpful. We have to have 3 negatives.
-1, -2, -3.
Okay,
We
so
space them out a little bit more than that so that we can get a bigger range.
-1.
well, we're gonna have to do to the 4th, so we don't want to do too high.
I know, but like if you do like.
Oh, we'll be fine. We'll be fine. We only have like -4 to 4.
Yeah.
We'll be okay.
67.
No, I don't want to do -67.
Why?
-2, -1, and then I'm assuming 1, 2, and 3.
Yeah.
Okay, and you're right, Angela, that if I was going to do it on a calculator, I would probably space my points more out further than that. But I only have -4 to 4 on my piece of graph paper, so
Okay.
we better hope that it's good enough for our purposes, at least. Okay, so I have to plug these x's in to get out y's, don't I? Okay, so on the right-hand side of the room, you guys do the negatives.
What?
You guys do the negatives. You guys do the positives. And I get to do 0.
I'm doing
That's not
0.
Negatives, positives.
Zero.
Do them.
Right here.
I'll do them all. You guys negatives, you guys positives. Let's go. Fill in your chart. The X's.
Oh, I'll do
Oh.
one.
I'm done with mine.
So
Of
I'm
course
lost.
you're done with yours. Yours is easy.
Okay, you guys do them.
I'll do one.
I got 2.
No, you guys have to do 1, 2, and 3.
No, I'm doing 1.
No, you have to do more than 1.
I'm doing -0.
Shh.
Why freeze it, Miss May?
Because I don't want you to see my work. Okay, so this is what you should have gotten. Did you get that?
No.
Nope.
I had.
Yeah.
I got -69.
I got 0.
For -3.
But you didn't use your negative. You didn't change your. A few times you didn't put the
Just
negative.
What?
Where'd the exponents go?
You did them. Okay, so what you're doing, like right here, I have -0.5 times 3 to the 4th. Okay, 3 times 3 is 9. 9 times 9 is 81. Yes?
Mm-hmm.
Okay, and then 3 squared is 9 times 3 is 27
Yeah.
plus 2. So that gives me -40.5, and then this is 29. And so that combines together to be a -11.5.
Would you grab these after?
Yeah, we will. Okay?
Why are the negative ones not negative?
Because when you take a negative number to an even power, it's positive.
So,
Because it'd be -2 times -2 is +4. Right?
Are you gonna give time to negative as a positive?
Right.
so
Okay.
how are you getting
217.
those answers out of that? Because I did 0.5 times I did first I did 5 point, and then I did 0.5 times 1, which I got 0.5 again. And then I did my got
Okay, order of operations tells me that I have to take whatever number to the fourth first. So I take all these numbers to the fourth first. Then I take half of that number.
Please come to the office.
Because 0.5 is half, correct?
I had the right math, this wrong math.
And then I take it and square it, multiply it times 3, and add 2. So all this means is I need to do correct math in the right order.
Yes.
Yes? Okay, so now we need to graph it. So I'm going to graph it. So -3 and negative, so that's like somewhere down here, right? And then +3 is somewhere down here. Hopefully that's about even. -2 is 6. And 2 is 6. And the only reason that this happens that I get both the same answers is if I'm taking things to an even power, correct? If I have an odd power, I'd have some negatives in there, wouldn't I? And then -1 was 4.5. 4.5. And 0 was 2. Correct?
Yeah.
So now I have to graph this thing.
How do you connect
It's a
them?
Y.
It's
To X.
What is it? Ooh, it's an M. It's an M, Miss Mick.
I missed Nick. We didn't know like good
Wait, why are
Okay.
there purple dots on it?
because that's -11.5.
I said
Oh.
Okay,
I thought you were
now-
supposed to connect them.
Now it says relative min and max. You guys have done, I did connect them, it's just through the words. Okay, so you guys have done minimum maximums before of a graph, but it's been a minimum, a maximum, correct? This is called a relative min or max because how many maximums do I actually have? I have 2 of them. So I have maxes at x equals what?
6.
X. Positive and -2?
Oh, I'm looking at that the wrong
Yep,
way.
you're looking at the Y's.
Yep.
And I had minimums, and I'm going to put relative max. And I had relative minimums. I only have one of those, don't I? At where? X equals 0?
Yeah.
And we need to find the average rate of change, but we are not going to have time. But these are X's. I need Y's, don't I? So if actually, we do have time. If I plug in an X, I get out a Y, yes?
Yes.
Do I already have -2?
Yeah.
Do I already have 0?
Yeah.
So I'm going to use -2, and I'm going to use 0 and find slope. So average rate of change, arc, y minus y. So 6 minus 2 over -2 minus 0. So 4 over -2 is -2. So if I pick right, like if I see this in here, could I use these 2 points in my chart so I wouldn't have to calculate them again? Yes. Okay.